If you leave them alone, they'll leave you alone.
Is it a girl?
I think it is. That's cool. It goes for a while.
Yeah, that stuff's definitely worth buying.
What should we name the fire?
Oh, sheep. No, that's a car. No, that's a...
Hey everybody, welcome back to the channel. I hope you're doing well. Hope you're having fun. Here it is, April 8th. Our first official race is today, but it was overcast, and of course, as usual, I wasn't ready to do anything, so I'm not at the racetrack. I'm making videos instead. But we are looking at one of my all-time favorite street and track cars, the 997 GT3 RS. Really, I don't think you can beat it. 500 horse, naturally aspirated, goes to 9,000 RPM. Just absolute primo example of motorsport as a street car. And the new ones are even better because of crazy computer modeling and probably additive manufacturing or 3D metal printing to us mortals. They make 88 extra pounds of downforce on the front end just because of the control arms. So really a neat piece of engineering. So with that kind of in mind, this is a continuation of something that we talked about a couple videos ago about utilizing OE level strategies in our tuning where possible. Just because it's the easiest software to use to show these examples, and currently one of my more favorite that I do a lot is, of course, we're going to use the Haltech. So some of this you may be able to do, but you might have to really think of how to repurpose tables depending on what ECU you are using. But the strategy is there for a reason. OEMs know that we're going to go beat on our cars, and so they're going to do everything they can to keep the car together because they don't want warranty claims. They want their cars to have a good reputation. So they have a lot of cool, interesting background stuff. We talked about using the drive-by-wire for error correction if it overboosts. We looked at that example in a Subaru. So we're going to switch to the Haltech software, and we're going to look at a couple examples. This is most likely going to be 2 episodes all of its own, just because I'm going to take the time to show how to set up the table, or how I set them up at any rate, because you guys are creative, so you might have some options and ways of thinking that, you know, I might be a little two-dimensional in comparison. So let's switch to the Haltech software, and the first one that we're going to talk about is one that is used in the EcoBoosts, and that is transient spark retard. GM uses it as well. So let's switch to the software and take a look about what I'm talking about. So when we get in a situation where we're making quick throttle changes, it's good to realize that there is a certain amount of lag time between what the manifold pressure sensor reports to the ECU and what is physically happening. It's not very long, but it does exist. And so in some situations on small turbos or higher compression engines, we can get in a situation where maybe we have too much timing and for a given RPM and boost level because the ECU hasn't been able to catch up. So I believe in GM it's called burst knock. Ford calls it transient spark retard or something. I'm trying to remember labels, but obviously you guys have come to appreciate that I don't always get those 100%. At any rate, the idea is there. It's to pull timing to correct for that in very rapid throttle changes. So looking at the map, it is a generic correction table here in the Haltech. I did name it transient spark. When we look at the axes, we have transient throttle load derivative. So that's the change in throttle in percentage per second. So obviously you only have 100% throttle, but per second, that throttle change can be several 100%. And that's something you can log in every ECU. I just have it up to 200% per second change. In this particular one, when we look at the log, you'll see what the values end up being. And then I'm only running in a small window, 2 to 6,000 RPM. This was on the Subaru, but I set this table up the same on every car I do. Because usually if we're above 6,000 RPM, we're also generally floored. We're not going to be doing a bunch of throttle changes. Possibly, I guess, if we were road racing, you might be in and out of vacuum. So depending on your application, maybe this is something you do want to extend. Looking at how the table conditions work, because this is important to keep in mind. You don't necessarily want it interfering with you at other times. So in the Haltech, that's where you get the opportunity to name it. So we named it Transient Spark. It is a generic correction. You would have to turn on the enable conditions. In this particular case, I have 3. Keep in mind, it doesn't matter what order they're in, but you do need to make sure that they're proper. And in fact, I just noticed that this one is not, so I'm going to have to go out to the car and change that. So the first one is RPM. So above 2,000 RPM, this table can come into play, and throttle position above 25%. Now you might need to play with that depending on if it gets in the way. Anytime we make custom tables, you don't want to step on your own feet. So maybe that needs to be 50% for you or more. In this particular example, I use 25. And then RPM is less than 6,000. So that just means that it's only going to run on this map. It's not going to continue to run if it is below or above those values. So that kind of establishes how to do it, and the easiest axes to use, in my opinion. Again, maybe you have some that you want to use. If you could do this versus 3D or 4D, maybe you would add another one. In this particular case, pressing F3, I only have the 2 axes to use. Because you could modify it versus manifold pressure also. I chose to do it this way because I'm trying to correct for the latency in the map sensor to the ECU and then the ECU's ability to react. So I didn't use manifold pressure. But you could use a table like this for other correction as well. So this is really good for fast spooling turbos on bigger engines where you have almost a supercharged effect. If you do have a supercharged motor where you can make instant boost, or some NA applications where you have maybe a small cam and a bunch of compression so you can make really high cylinder pressure, or you're using the VVT to make high cylinder pressure, this table could be your friend. Just remember as you go through logs to keep in mind that it's there. So let's do that. Let's switch to the log. We're going to see it in action and see if I did stepping on my own feet as we were using it. So this is a log that we've looked at previously when we were talking about using drive-by-wire to correct for boost error. So you might recognize parts of it. But looking down at the bottom, looking at transient throttle enrichment load derivative, or you can put in pretty much any of the transient throttle load derivatives where that is changing. We see that it got to a peak of 53.8%. So it came into use on that table. We see here it pulled 2.7 degrees. And if you were to look at the dyno sheet, you wouldn't see any change in power for how fast it pulled the timing out and how fast it put it back in. Because when we start to look at the throttle change versus the actual throttle value, here at 0.791 seconds, I'm 30% throttle. I'm 100% throttle at 1.32. So basically in half a second, the drive-by-wire had fully opened and it pulled that timing out just a couple of degrees to keep the knock away. Of course, this car was on ethanol, and this is going to be mostly a pump gas or lower octane, but maybe high boost or high heat solution. I didn't necessarily need it for ethanol, but it's there because it's also a flex fuel car. So I'm going to use it all the time. It's just what's going to happen. I could make one of those conditions in there, ethanol content, I guess, if I wanted, so that it wouldn't come into play at all on ethanol. But as I observed on the dyno, it didn't hurt anything, so there's no reason to use it. So now, I did mention about setting upper limits and making sure that we don't step on our own toes. Now, because the throttle was changing to correct for boost, we can see here that there was some transient throttle change as it was chopping throttle. When we look at the value, it was a 33% throttle change per second as it chopped. So it referenced that table. It pulled a degree out. Now, it put it right back in, but then it pulled it right back out. And when we look at where that is happening, it's happening above 6,000 RPM. You'll remember that I did set the limits in the map between 2 and 6,000. So I did that because I learned the hard way that things were going on. Things were changing, and I thought it was knock. And I'm like, where's my timing going? Because I didn't remember. Now see, we have a 62.5% throttle change. Even though it's going upwards, it's a throttle change. And so it's still pulling timing. We can see that it's not pulling much. It's only a quarter degree, 0.2 of a degree, but it's a 75% throttle change. And it's 7,500 RPM. So it's almost wound out. That particular log, it says the max is 7716. So it was pretty much done and over. So when you go to set that table up, it is important to limit its function. I wouldn't use 2 TPS windows if you're using this drive-by-wire solution as an OE strategy that you wanted to incorporate. RPM is a good way to limit it because most of the time that we're going to run into the knock problems are going to be at low engine speed when we have a lot of time in the combustion chamber for bad things to happen. When we're revved out, everything happens so fast, it's really hard to get knock. Not to say it doesn't happen, but it's really hard to get. So we don't need it as much at high RPM as we do low RPM on fast spooling turbos. So I think that covers that one. We're going to move to the next one. If that content is something that you like, please consider giving me a thumbs up. If you haven't subscribed already, please consider doing so. Definitely leave comments for positive, negative. Let me know where I can improve, what you guys want to see in the future. It just helps the channel and it helps get you the content that you want. If possibly you have a friend or a community group that can benefit from content like this, please consider sharing it with them, Facebook, Instagram, wherever you want to go. Lastly, if you want notified as new content is added, simply click on the bell icon and YouTube will do that for you. Thanks again, guys. Take care.